Hi, I'm Sunil Yu. I'm the CISO at JupiterOne, and thanks for having me to be able to share my perspectives on the security of data and resilience. Now, when I was the chief security scientist at Bank of America, one of the things I looked at was the problem space beyond just data security. When we think about security, there's a lot of other things that we need to secure, and data is certainly one of the major aspects of it. But we also have to secure a lot of other things. And so I came up with this model called the Cyber Defense Matrix. And the Cyber Defense Matrix consists of two dimensions. On one dimension, it's 5 things that we care about: devices, applications, networks, data, and users. And the other dimension is 5 functions that we perform in cybersecurity. And this is based off what's called the NIST cybersecurity framework. And those 5 functions are identify, protect, detect, respond, recover. Think of these as nouns and verbs. And you end up with this nice 5x5 bingo card, which I can use to essentially understand the full space of what consists of cybersecurity. And again, data is one major aspect of it, but you can see from the matrix that there's more to security than just data. Now, when it comes to AWS, JupiterOne is a major customer of AWS, and when I'm trying to secure my environment, there's a lot of great AWS services that we can put to bear to secure our devices, our applications, networks, data, and users. And these services are useful in being able to understand how do we tackle some of the challenges that we see in security. On top of that, we also have a lot of marketplace vendors that we can turn to help us address some of the challenges that we see. Now, if you looked at the 2 slides earlier, you'll notice that there's an obvious pattern that has emerged. And if you see it, you'll see that on the right side of the matrix, there are very few technologies. And it made me wonder, wow, why is that the case? And I came up with 2 theories. On one, it's represented on the bottom of the matrix, this degree of dependency between people, process, and technology. Perhaps we have a greater dependency on technology on the left side of the matrix under the functions of identify and protect. And as we shift to the functions of detect, respond, and recover, we have a greater dependency maybe on people. Now, that was one of my theories, but I also discovered another pattern that pointed to some interesting, remarkable outcomes. And to be able to share that particular perspective, I have to give you a quick history lesson. So let's go back to the 80s. Dell and Gateway made computers cheap. We bought tons of them. And the first problem that we ran into is answering the question of what did I just buy and what business function did it support? And so we came up with solutions to help us inventory our assets and do asset management and to do mapping to the business functions and so on and so forth. Fast forward 10 years, and we started seeing viruses. We started seeing people walk into our networks. And so we came up with solutions like antivirus and firewalls and tried to tackle that particular problem. Fast forward 10 more years, and we started getting inundated with all these logs, thinking that there may be intrusions. And we needed a way to analyze those logs, and so we came up with things like intrusion detection systems and security incident event management systems. Fast forward 10 more years, and we realized that many of us were already breached. And so we took an assumed breach stance, and we needed firefighters and firefighting tools because there were fires everywhere. What's remarkable about the sequence in history that you see is that each era maps nicely to the NIST cybersecurity framework. So those 5 functions that you saw previously in the cyber defense matrix, the 4 of the 5 functions map to those 4 eras. So in the 80s, we had an identify problem. The 90s, we had a protect problem. The 2000s, we had a detect problem. And the 2010s, we had a respond problem. So naturally, the question is, what will happen in the 2020s? Well, the last function of the cybersecurity framework is the function of recover. So the 2020s is going to be the age of recover, or you can say resilience. Now, if we think about the challenges of recover, the question is going to be, well, what are the type of attacks that we might see that undermine our ability to recover? And to understand that, let me share with you one of the core principles that we rely upon in security, which is the notion of this CIA triad. So CIA stands for confidentiality, integrity, and availability. And the question that I ask myself is, what is it that will undermine each and every one of these? And if you haven't already guessed, the epitome of a recover-oriented attack, or something that will cause us to, our environment to be irrecoverable, is something like ransomware. And ransomware is currently a pretty bad epidemic worldwide today. And if you think about the nature of ransomware, it's trying to undermine every aspect of confidentiality, integrity, and availability. In fact, many attackers actually hit you multiple times to say, one, we stole your data. In other words, we've undermined your confidentiality, and we're going to share the data that we just stole from you to the rest of the world unless you pay us a ransom. And furthermore, we've denied you access to your own data. We've corrupted it, changed your integrity, and we're making it unavailable for you. And so until you pay us another ransom in some cases, we're going to lock it up so that you can't get to it either. And so it's creating this really interesting challenge for us because attackers have found a way to monetize ransomware to extract maximum value for them, at least, in terms of our situation becoming irrecoverable. So, all right. Now, the question is, what kind of solutions then do we need to look for? And if we consider the history lesson from the past, it turns out that each of the eras required and demanded a new solution. The solutions from the past did not address the problems of the present. And so when we look at the age of recover, the solutions of the past aren't going to help us here. And so we need to look at new types of solutions, new types of approaches. And so as I scoured the marketplace to find these types of solutions, I discovered a few things that did help us recover. And these are things like, for example, serverless architectures, things like content delivery networks, and even design patterns like copy on write, where you never delete anything, you keep appending. Solutions like even blockchain, for example, helps us recover, and things like Docker containers can help us recover. And overall, AWS as a solution space is something that helps us quickly recover from outages and so on. So as I looked at all these different types of solutions to the recover problem, I noticed a common pattern that undergirded all those. And that common pattern is what I call the DIE triad. So DIE stands for distributed, immutable, and ephemeral. And each of these different attributes of being distributed, immutable, and ephemeral provides security value. So for example, if I'm trying to deal with a distributed attack, the best way to ward against that is to have a distributed service. When it comes to immutability, one of the challenges that we have in security is finding the anomaly. Well, if nothing's supposed to change, then finding the anomaly is really easy. And then lastly, attackers tend to want to have persistence in your environment. They want to get in and stay in. And if you have resources that are highly ephemeral, then establishing persistence is extremely hard. So DIE provides this sort of security value. But what's actually more interesting is that if you design systems to be distributed, immutable, and ephemeral, it actually helps offset the needs for confidentiality, integrity, and availability. Now, in this regard, it's providing a new pattern for how we can think about not necessarily just securing our environment, but perhaps finding ways that we don't have to secure our environment at all. And to understand how to apply DIE, let me give you some examples of how I used DIE at JupiterOne. So first is, there's a lot of services within AWS that map nicely to the DIE triad. And so here's a mapping of some of those services. And by the way, again, this is my opinion, so and I'm happy to take input if you have some ideas in terms of where these things go as it relates to DIE. But the idea is that there's a lot of services within AWS that help us build systems to be distributed, immutable, and ephemeral. Now, you can think of these components as like bricks. Previously, we were building with wood and straw. And building a very defensible environment is kind of hard when you have just wood and straw. Now we have bricks. But you know what? You can still build a pretty crappy wall with bricks if you don't use the right design patterns. And so you still need a well-architected wall and an environment to be able to ensure that these bricks are being put to the right task. So you still want to follow things like the well-architected framework. But nonetheless, we at least have a sporting chance to build defensible infrastructure and defensible systems. Now, So applying, looking at the different services is one way that we have applied the DIE triad at JupiterOne. And the other way is, I have to use a different analogy, but one analogy that we've used is to understand the distinction between pets and cattle. So for those who are familiar with the cloud native concept, hopefully this will be, you'll be familiar to you. But for those who don't, let me walk through what's the difference between pets and cattle. So pets are things that you have a familiar name for. When it gets sick, you take it to the vet, and you like giving it hugs. These are things like your social security number, your personal laptop, your server under the desk. Cattle, on the other hand, you give it a name that you can't even pronounce, full of strings and numbers and characters. And when it gets sick, you shoot it and you move on. And these are things like Lambda functions, credit card numbers that continuously change, Docker containers, and so on and so forth. And the perspective here is that when it comes to pets, you have an obligation to ensure that they are secure. And so you CIA your pets. Cattle, on the other hand, you design them to DIE. Now, you may wonder, okay, well, great, I get the concept, but how do I know what's a pet and what's a cattle? And this is, again, where DIE comes in really handy, because DIE is actually very measurable. And let's use an example here with E, which is ephemerality. The unit of measure for ephemerality is time. So the question here is, how long-lived are any of these resources that we have? And what I can do is basically capture the uptime, let's say, or the lifetime of a given thing, and then create a threshold that says anything older than this particular threshold, and the threshold can be arbitrary for whatever, but you establish it for your organization and say, anything over this threshold, I'm going to declare that to be a pet. Anything under that threshold, I'm going to declare it to be cattle. And the goal here is to try to create policies and incentives that drive the number of pets to be as low as possible, and to drive the lifetime of cattle to be as short as possible. And so to move this curve down and to the left. So having this sort of construct helps us quickly discern what is pets, what is a pet and what is cattle. And the reason why this is important is because in many organizations, we have a mechanism to say, this is a critical system, this is my crown jewels. But that's usually somebody's opinion. And that opinion, how do you arbitrate that when you have two business leaders that says, my pet's the most important thing? Well, it turns out DIE helps us here, because DIE is a very objective measure that we can use to be able to say, this is more important than that. Now, again, it requires the business to still weigh in, but nonetheless, it provides a very tangible mechanism to be able to say, I think that this is an important, critical crown jewel. And to give you an understanding of how this might work for other things besides technology, let's use a biological example. So consider, for example, the cells in your body. What cells in your body are very short-lived? Things like your skin cell, right? What about what are cells in your body that are very long-lived? Those would be things like your brain cells. Now consider, which of those cells are CIA'd, which of those are crown jewels, and which are designed to DIE and exposed to the wild, right? Now, one of the things that we have to think about when we have this construct is to say, do we actually need to spend time and effort and money trying to secure those assets that are meant to DIE? And the answer is no. In fact, if you tried to secure, for example, all your skin cells, you'd end up having to buy something like an Iron Man suit, and those cost billions of dollars and is essentially unaffordable for pretty much, even if you could afford it, you wouldn't want to spend money to do exactly that, because it's just a waste of money. But you spend money on those things that are important to you, your crown jewels. And to be able to use the DIE triad to quickly discern what's important from what's not important is something that the DIE triad does. And that's what I use at JupiterOne. Now, with the DIE triad, it changes also how we think about our role. So right now, for many of us, we serve as veterinarians, cyber veterinarians for our cyber pets, trying to take care of these pets and making sure that they're taken care of. But we should also think of our role as being pet control officers, Because if I think about the cattle, for example, the natural evolution of these cattle is to become older over time and become pets that we didn't intend to adopt. And the perspective here is that I want to serve as a pet control officer that says, do we really need this cattle to become a pet? Do we really need this, this resource to have to be secured? And in most cases, the answer is no. Consider going back to the cell analogy. What do you call a skin cell that lives too long? Cancer, right? And what do you do with cancer? You cut it out. And so that's what we want to think about for a lot of the resources that are meant to DIE. We want to be very proactive in cutting those out and serving as a pet control officer that ensures that if the business chooses to adopt a pet, then that's done by deliberate choice and not accidental. So in this context, for me at JupiterOne, I use the product itself to keep track of this. And so I have these dashboards that help me understand how many pets do I have, and which of my assets are starting to look like pets, and perhaps my favorite metric, which is how many cattle have I slaughtered. And again, I'm sorry for those who are vegans and vegetarians, but hopefully you get the idea of the concept here. The perspective here is that we want to exercise as much pet control as possible and ensure that the resources that we have, the few resources that we have to secure our environment are spent on those things that matter the most for us. With all that said, a lot of people ask me, well, okay, I get that for servers, I get that for infrastructure, but what about data? Isn't data almost always a pet? And I tell you, it's sometimes it seems like that's the case. And one way that I've thought about this is to look at the AWS shared responsibility model. And if you look at that model, interestingly enough, you have this spectrum of things where on the bottom are things like servers and infrastructure, and they generally tend to be very cattle-like, at least from a customer standpoint. We treat them as cattle. But you look on the customer responsibility side, and on the top, what do you see at the top? You see customer data. And interestingly enough, it's if I consider the spectrum between cattle and pets, it's at the far end, which means that it's the thing that it seems to resist being anything but a pet. Now, the goal that we would have is to try to shift this balance and say, how do I get more of my environment to be cattle-like? And in the cloud, we've seen an emergence of new technologies that help us shift that balance from being more pet-like to becoming more cattle-like. And so there are tools like JupiterOne and Cloud Security Posture Management and Cloud Workload Protection Platforms and a whole bunch of other acronyms that help you address this challenge and make that distribution more cattle-like. But again, it still makes it seems like it's hard and challenging for us to get to this point where even the data itself is anything but a pet. But what I've discovered is that there's this new and emerging class of technologies that gives us a chance at turning data pets into data cattle. And it's privacy. It's privacy-enhancing technologies. And if you've ever looked at the privacy space, you'll see that there's all these buzzwords that make up the privacy space. But if I started aligning them towards the DIE triad, or the principle of pet control, you can now see how DIE could also work with data as well. And so things like data minimization is a form of pet control if you think about it. But there's all these other mechanisms that we have in the privacy space that help us make data more distributed, more immutable, or more ephemeral. Now, in the context of data, there's still going to be some challenges that we'll have to work to because sometimes data needs to remain persistent, right? But nonetheless, I hope that the DIE triad provides a mechanism to think through how do we build more and more of our environment to be DIE rather than CIA? How do we take the first step towards making it not require security at all? Because that's what the DIE triad offers as an alternative to the CIA triad. And if we're trying to deal with the age of recovery, then perhaps that is the solution for the future. So thank you very much for your time.